our 54s, really, I think the first one that we've done that's had a vertical shift, which means, what's the chance of me giving you a vertical shift on the test? Probably not very big chance, except for probably there's going to be a nice, good graphing extra credit that's definitely going to have a lot of stuff going on. But it doesn't hurt to think about this, of what's happening for cosine and sine. Remember, the period is 2 pi over b. So the period hasn't changed, but the amplitude is 2, and it has a vertical shift of up 3 units. So my whole graph is going to shift up 3. So we've spent a lot of time on our tangent and cotangent and secant and cosecant, but remember, sine and cosine, whatever your period is, you can always pick your 5 key points as starting at 0 and ending at your period, and taking half of it and half of it again. And when the period hasn't changed, those 5 numbers should be the x and the y-axis all around the unit circle. If the period does change, right, you still divide it in half and divide it in half again, and you'll get those same values. So if you need an x/y chart, remember, you're welcome to, but you don't have to make these graphs. So I'm going to go to 5, and take half of it, and half of it again. And don't forget to label your axis on the test. And I'm okay with you skipping every other one, but don't just label the first one and then not label the rest of it, because I want to know that you know, like, what that full period is to do that. And normally with an amplitude of 2, we would just go up to 2. We're shifting that up to 3. So think about that. Normally the highest it would be is 2, but we're going to go 3 more than that. So I think we can go for 5 on this. And if you don't mark what your y-axis is going by, then I just kind of have 1. Again, I'll give you like the grid, but then you're going to label your x and y-axis. And so you can actually plug this in. Normally at cosine, remember, cosine starts up on the y-axis. Normally it starts up at the amplitude, which is 2. This plus 3 means I'm going to go up 3 more than that, which means at 0, I do believe that you can die there. And then at pi halves, the cosine of pi halves is 0. So normally we go back to 0. But we're going to add 3 to that, which means now at pi halves, I'm going to be up at 3. The third one should give me my lowest value for cosine, which is -1 times 2 is -2. Then add 3 to that means that really my lowest value now is 1. And then remember, it just goes down and goes back up. So at 3 pi halves, I'm back to having a cosine value of 0 plus 3. And at the end, I should always end where I started, which is back up here. And so those are on sine and cosine. I should have 5 points. And it doesn't keep going up, right? So don't make arrows that keep going up. It's going to turn and go back down. And I want you to make 2 complete periods, which means you could just keep going positively, but I usually just go negative. And remember that cosine is even, so it's the same on this side. So much easier when you have that graph paper on your test to follow the points to make it look really nice. But you can see that we've shifted, if you think about that x-axis, we've just shifted it up, right? 3 units. And so that's what normally cosine looks like. We just shifted it up 3 units. And so we give us many of those. Definitely on the no calculator part, you're going to see a sine or cosine. Maybe. Then the rest of these with the asymptotes, remember that it's all about finding those asymptotes. So you need to study that if you don't know it already. Tangent and secant have the same way of finding their asymptotes, because tangent and secant both have cosine in the bottom, which means their asymptotes are both going to be set to where cosine equals 0, which is at -pi halves and at pi. And just like the one that was on your quiz, if you know that part, then you just have to make sure you're doing the algebra correctly to solve that for x. When you divide by 2 there, you're going to get negative pi fourths and pi fourths as 2 consecutive asymptotes. So you have to know what to set it equal to, and then you have to know how to solve that correctly. And you also have to know how to pick your points or what it looks like. So, negative pi fourths. Again, unlike that worksheet that we did, all of my graphs will be blank, which means you can make your x and y axis. Remember with tangent, we have that one in the middle. So if I make my next one, right, I'm going to skip that one and then go to this one. So either you have to look at how long this is, or you have to count by pi fourths. That's what I do. This would be pi fourths. This would be 2 pi fourths. So that means this would be 3 pi fourths, right? Equally spaced. It's the one in the middle. And you only have to graph 2 periods, so you really could stop there. If you label more, make sure you fill your graph text more from there. And again, I think the best way to study these is not just stare at ones you've graphed already, but practice them. Practice some either redoing these, or pick some that you have answers to, or you could look in the back of the book for the answer, or you could graph on a graphic calculator or on an online graphic calculator and check your answers. Make sure that you can graph these. And then again, you can always actually pick the point. Some of my kids in 6th hour really struggle. They keep mixing up the asymptotes for tangent and cotangent, and I told them, like, you can always check if you're right. Actually plug in 0, and this would be on the calculator portion of the test, which means even if you don't know what the tangent of 0 is, you could type that in your calculator, and if it's undefined, then you know you've done something wrong, because you shouldn't have an undefined value there if you don't have an asymptote there. So you can always kind of check your work that you did this correctly, especially on the calculator portion of the test. But tangent of 0 is 0, because tangent is y over x, which would be 0 over 1. So that's why halfway in between, you always get 0. And you can even check this one at pi halves on this one. 2 times pi halves would be pi, right? So you can actually check that you're doing that correctly. And if you're not sure which way it goes, you can check, right? Half of pi fourths is pi 8. And if you plug in 2 times pi 8 there, you get tangent of pi fourths. Which again, even if you don't know the value with the calculator, you could type that in, tangent of pi fourths, and it's 1. So it tells you that this side is going up to 1, and this side is going down to negative 1. I do want to see the 3 points on this, all right? Because remember, like, if there's a 4 in front of this, it's going to go up to 4. So if you don't make those points, and I trace over where the point should be, you will get a point to count for not going to it. That is 2 periods of tangent or cotangent. There's 2 sets of asymptotes. Questions about that one? Alright. Cotangent. Cotangent has sine in the bottom, so remember that cotangent and cosecant asymptote, you can always set that equal to 0 and equal to pi. That's the part you got to know for tomorrow. And then you solve it. So I told you that I'm not giving you any to graph with a phase shift. And I ask you about a phase shift, and I'm not making you graph it, which means cotangent and cosecant will always have an asymptote at 0. And then it's just by the next one. Is pi thirds. So to me, that's the big difference between tangent, secant, cotangent, cosecant. So this 0, this pi thirds. It's really easy to make 2 periods on this, because you can just go negative into the pi thirds. We go to the next one, we're just counting by pi thirds now. So this would be 2 pi thirds. Right? And there's an asymptote at all of these. There's an asymptote at pi thirds. There's an asymptote at 0. There's an asymptote at negative pi thirds. From 0 to pi thirds is just a distance of pi thirds. So every pi thirds. So you can make a lot of these. Then it's just like tangent, in that halfway in between these should always be your zero. And as long as you can take half of your asymptote, again, you can check this on your calculator. Half of pi third is pi 6, and you can plug pi 6 in there, in those, and check on your calculator that you get 0 there. And you do, because pi 6 is going to give you pi halves, it's cotangent of pi halves, x on top, so you get 0 over 1. So you get 0 But again, if you're not confident in that, that's why I put these on the calculator portion of the test, so you can actually check some answers there, that you're not just using everything memorized from the unit circle. And if you get confused about which way to go from there, again, you can use your calculator to help you. Be careful again, because it's a negative in front, right? So if I took pi 6, so half of pi 6 would give me pi 12, it should always give me pi 4 something. It does. And cotangent of pi 4 is still 1, so normally cotangent goes up this way and down this way. If a negative in front means that it's actually going to go down, right? So that means that it would go down to negative 2, and this side would go up to positive 2. And again, notice if you just kind of winged it from there and you didn't mark that it went up to 2, you might not have it going through the grid. And once you get one above, it just repeats itself. Even if you get your asymptotes wrong tomorrow, if you have the shape right, and you have it stretched to a factor of 2, you're going to get some credit there, right? It is kind of, you're not going to get all the credit if your asymptotes are wrong, because to me, the asymptotes are the most important part to make sure that your graph is where it should be. But at least draw me a graph that looks like cotangent. Show me that you know the negative means it's flipped. Show me that you know the 2 means it's stretched. Okay, so cotangent and tangent look like that. Sine and cosine are nice curves. Remember that secant and cosecant are the like the parabolas, up 1, down 1. 2 periods of this, I think people struggle the most on this one, because with asymptotes you think 2 sets is enough, but secant and cosecant have a period of 2 pi over b as well, which means that you have to have, what, 4 sets of, like, parabola up, parabola down is 1 period, parabola up, parabola down is another period, so you have to have like 4 parabolas to get 2 full periods there. Step 1 is, again, knowing what to set your asymptote to. And if you get stuck, this is how I've always remembered it. Secant is 1 over cosine. So then I ask myself, that can't be 0. So where does cosine equal 0? At negative pi halves and at pi halves. And so that's how you kind of remind yourself when you're doing that. But I think we should get pi and negative pi for this. Do you agree with that? When it's dividing by 2, you have to multiply by 2. So at negative pi and pi, and just like tangent, right, you have to equally space your asymptotes. So don't tell me that there's an asymptote at 2 pi, because this is a distance of 2 pi. So I have to skip that one in the middle, and then this would be 3 pi, right? So I'd have an asymptote here. I don't know why I always, tangent and secant, I always spread apart more than I do cotangent and cosecant. So then if I went backwards here, because I ran out of room this way, I would skip this one, and this would be negative 3 pi. And you can see that I should have made these closer together, because 2 sets of asymptote make 1 period, which means if I'm going to make 2 full periods, I need 4 sets here, which means I'm going to go back 1 more at negative 5 pi. And again, if you're not confident in your asymptotes, check them. Plug in pi, plug in 3 pi, and make sure that it's undefined when you do that. Right? So if you plugged in pi, you get pi halves, and at pi halves, the x value is 0, so that means you would get 1 divided by 0 there. Or you can check on your calculator, it will tell you that. I use what I know about cosine to graph this, so you tell me if this makes sense or not. Cosine normally starts up here, right? So normally secant is going to have that parabola going up at whatever this number is, right? So it needs to go up to 2, down to -2. But that negative in front means that it's flipped over. So instead of it being up like this, it's going to start here. And secant and cosecant, I am the most lenient about in terms of points of if your asymptotes are right, you really just have to make that 1 point for me. You can pick other ones if you want, but I just use the asymptotes to kind of guide me on that. And if you get the first one right, it just alternates, right? At the next one, it normally goes down, but it flipped over, so it would go up. That's 1 period. Alright, so that means I have to do 2 more, which again is fine if you went the positive way. I just ran out of room, so I went this way. So this side's going to go up, and then this one. But just know that the period is 2 pi. Pi over b, which is why I have to make more than that. Oh, one more. Let's have all the answers here. We'll just take a long. We graphed a few like this one where it has pi in the problem already. Remember, if pi's in the problem, then your x-axis is not going to have pi in it because the pi's already up there. But I do this the same way. Cosecant is 1 over sine, so its asymptotes are normally at 0 and pi. So I can set pi x equals 0 and pi x equals pi. So I get asymptotes at 0, and pi divided by pi is 1. So when pi is in your problem, your x-axis doesn't have pi in it. So my asymptotes are going to be at 0, at 1, at 2, right? Even space at -1, at -2. Which is again why labeling your axis to me is the most important part. Shows me that you understand what the period is. It shows me that you understand where the asymptotes are. I would probably say, off the top of my head, points-wise, I would say like 40% of your test is graphing points. So really make sure you have practiced these and that you can do these. I know on day 2 each of those graphs are 5 points. And then remember that cosecant is the opposite of sine. So sine normally starts at 0, right? It normally starts at 0 and goes up and then down. So I have my parabola up and my parabola down. This one has nothing in front, which means that my y-axis is go to 1 and -1, and that is just going to be up. And remember that it just alternates, and this side would be rather down. Again, Wednesday's part of the test is much heavier on the graphing than tomorrow's part of the test. Tomorrow's part of the test, a lot more just no calculator stuff, evaluate the function, solve over the given interval, inverse trig, and a couple graphs. But nothing is as complicated as the one. So, as you're finishing 60, if you haven't finished it, I believe this is what the book asked you to find on the next 3. So I'm going to let you kind of check your answers with those, especially if you haven't checked your odd ones already, and then let me know if you have questions on those. They did ask for domain and range on those. Am I going to ask you for domain and range? No. But when you're graphing, I have to think about, sine and cosine have to go from all the numbers. They're the only ones that don't have asymptotes. Questions on any of these? Yeah. And if I don't, then I can't mark you wrong for rounding differently, right? But I try to tell you what to round to. And I think on 69 and 70, they ask for both degrees and radians, so definitely make sure you check, right? 69 and 70 are definitely calculator questions, but make sure you check whether it asks for one or both, that you're in the right mode on your calculator doing that. Questions about any of these? Definitely you're going to have questions like 61, 62, and 65, asking for all these things, I'm definitely going to, because I'm not making you graph a phase shift, I'm definitely going to give you some questions that ask you for the phase shift where it's C over B. And remember that the way we wrote that out, it's Bx minus C. So when you do the phase shift, you don't say negative 1/2, just like when we did the x minus h stuff. Like it's minus in the formula, so that's a positive C value. If that was a plus sign, it would be a negative C value. Think about, like, that's a positive C value, meaning it's moving to the right. If that was a negative C value, that means it would be moving to the left. And so kind of think about your transformations when you do that. Questions about that? Okay. So I'm going to give you a second to digest these answers, and then we'll definitely talk about 87 and 88 in the bottom, and then any of the other ones there. These are the ones that lots of people had questions on throughout the chapter, these solving equations over a given interval. These would be all no calculator questions. Questions on these? So secant, cosecant, and cotangent. For me, I always change it to the reciprocal one first because my mind works better that way. So like number 80, when it says secant x equals 2, the first thing that I would say is that's the same as saying cosine x equals 1/2. Hear that? And so because I don't, that hurts my head. But if I change it to the reciprocal function, that's the same thing, right? If secant is 2, then cosine is 1/2. And then I've just got to figure out what interval am I looking at. So I'm looking between pi and 2 pi, which means I'm only looking in quadrant 3 and quadrant 4. I can say right away I know the answer is not in quadrant 3 because x is negative in quadrant 3. So now I'm in quadrant 4 of what angle has a cosine of 1/2, or an x value of 1/2. And that would be this one down here, right? So that's 1/2 squared root 3 over 2. So that's what I do on all of those. The same thing on the cosecant. even though the reciprocal of -1 is still -1, it helps me if I rewrite that as the sine equals -1, because I just work better with sine and cosine than I do with secant and cosecant. And then 0 to 2 pi, the only place between 0 and 2 pi where y equals -1 is at 3 pi halves. And then for the cotangent, probably that's the one that you don't really have to change it, because remember that cotangent is x over y, tangent is y over x. Either way, you have to think about it as a fraction. So it's kind of up to you if you want to change it or not. You could change that and say that -1 over square root of 3. And between 0 and pi, I know that's quadrant 1 and quadrant 2. The tangent is positive in quadrant 1, which means I know I'm in quadrant 2. So it's just figuring out which one makes it a tangent of 1 over square root of 3 or a cotangent of square root of 3 over 1. And we can see the answer with this one. Because it's negative radical 3 over 2 1/2. Remember, tangent y over x. That or x over y. So that's my advice, is flip them. Like, change them to sine, cosine, or tangent. Notice on 71 and 72, there's no interval, right? They don't have to give you an interval if it's an inverse, because the inverse tells you the restricted domain and range. So kind of the difference between those types of problems. And then the ones at the bottom here, right? Notice that on 85 and 86, it does just cancel out. You could just work it out and it would still get the same answer. But notice on 87 and 88, that did not work. Both are kind of different here. 87 to me is a triangle question of 3/5 is not in my unit circle. So if I solve this on a no calculator part of the test, I would be like, what? 3/5 is not in my unit circle. But just like the ones we did with x's, right? This is like saying the sine of some angle equals 3/5. So you can draw a triangle. And sine is opposite over hypotenuse. And I think way better than the x stuff that we did. These are just numbers, so you could just do Pythagorean theorem, and you should get that the other side of that triangle is 4. So again, the inside part gave me the triangle, and then I did the outside part. Find the tangent of that angle. Tangent is opposite over adjacent. So that's where they got the answer of 3/4. 88 to me is a little trickier, because a couple ways to think about it. But one way to think about it is cosine is an even function. So is first of all, negative pi 7, is that in between our range of 0 to pi for inverse cosine? Right? Inverse cosine is 0 to pi. Negative pi 7 is not in that range. But the reason that the answer is pi 7, two ways to look at it. One way to look at it is cosine's an even function, which means that the cosine of negative pi 7 is the same as the cosine of pi 7. So you can just kind of disregard the negative because it's the same value, which is why you disregard that. Is pi 7 in the interval from 0 to pi? Then you can just cancel it out. So that was kind of making you really like apply that even function. I'm not going to be that mean on the test tomorrow. The other way to think about it, if you could think about negative pi 7 would be, like down here somewhere. Really small, right? Negative pi 7. And then you could think about that the reference angle up here would be positive pi 7. And the x value is the same on both of those. So that's, again, kind of, instead of talking about even functions, you think about reference angles. That works as well. But I thought that was kind of a good thinking question. I probably won't be as tricky like that. But 87, I definitely could give you something, either to draw a triangle with x's or to just draw a triangle with numbers. I could give you something like that. 94 with the x's. That's just like the ones we did in our notes. And then I'll let you check 95 and 96 for a minute. Both of those, they are asking you to find the height. Remember, I also could ask you to find the angle. And remember, if you're looking for the angle, you can use inverse trig. Questions on those? So 94, again, just like the one with 88, if they give me that inverse trig inside there, I know that's like saying the cosine of some angle equals x. So I'm going to draw a triangle and label one of those angles as theta. And whether it's sine, cosine, or tangent in there, you have to label the triangle appropriately. Cosine is adjacent over hypotenuse. There's no fraction here, so I make it into a fraction. And then you have to solve for that third side of the triangle using Pythagorean theorem. So just watch your negative signs, right? If I call this side b, then I would get x squared plus b squared equals 1. So if I subtract the x squared over and take the square root of both sides, that's where you get the square root of 1 minus x squared, as opposed to like a number on 88. And then again, the inside part just gives you the triangle. And then what I'm trying to do is write an expression for tangent. So now I just take the tangent of that angle, and tangent is opposite over adjacent, which is where they got the square root of 1 minus x squared over x. And remember, that one doesn't have a square root in the bottom, but you don't have to rationalize those. You can, but you don't. Other questions about that? One thing that's not on this review that I know for sure I'm going to put on your test is asking you to find 2 consecutive asymptotes. Not graph it, but find 2 consecutive asymptotes when there's a phase shift. So just make sure that, and I know we practiced this on our notes. So if I said something like, find 2 consecutive asymptotes of 3 tangent of 2x minus pi thirds. Again, I would never make you graph that by hand. We graphed those on the graphing calculators to see what the phase shift is going to kind of change everything. But if you know what the set is equal to, it's just like algebra. Sometimes the pi really throws everyone off to do that. Remember that this number has nothing to do with the asymptote. It's right here, right? Anything that's in the trig function, the bx minus c. So you're going to set that whole thing equal to where tangent normally has asymptotes. And where are 2 things that we normally set tangent equal to? Negative pi halves and pi halves. And again, because we're adding something here, you can't just say one's a positive and one's negative. It's not going to work out that way. So you have to really watch your algebra on that. This would be on the calculator part of the test, as I'm okay if you use calculator to help you add here. But just make sure that you maybe look back over the notes. I think that was 4, 5, day 2 is the day that we did this. But if I was going to solve this, right, I'm going to add pi thirds. And I can add those. They both have pi in them. Add the numbers and then put the pi back with it. Right? So that would be what? Over 6. That would be 2 pi over 6. That would be negative 3 pi over 6. So you can just do negative 1/2 plus 1/3 on your calculator, but I think you should get negative pi 6. Right? Do you agree with that? And then I'm going to divide by 2, which is the same as multiplying by 1/2, which means that this would be at negative pi 12ths. And then I have to do this side too. Don't just say the other one is pi 12ths, because it's not going to work out like that, more than likely. Over here, when I add pi thirds, right, that would be 3 pi 6 plus 2 pi 6, which would be 5 pi 6. So when I divide by 2, that would be 5 pi 12. Which means if I was going to graph that, that would be my first set of asymptotes at negative pi 12ths and 5 pi 12ths, and then I would evenly space them from there. Um, but I just want to kind of make you do that. The phase shift would be C over B, which would be pi thirds divided by 2, which would be a phase shift of 5 pi 6. So that graph would shift pi 6. Right, so I know that wasn't on the review. Again, if you're looking for things to review for tomorrow's part of the test, just basic graphs, check and make sure you know the period and what each of them look like. Even if you just try to graph the basic sine, cosine, tangent, cosine with nothing else added to it. And knowing your unit circle, practice that. Knowing the restricted domains and ranges for your inverse trig, those would be what I would say is the most important for tomorrow. And then tomorrow night we should be studying like the harder graphs, period changes, stretches, changing the asymptotes, finding consecutive asymptotes. Story problems, definitely going to be on the second day. Using your calculator just to do trig on calculator to get up and spread. I'm not going to be here tomorrow, so I will read directions with the sub. I can spread out like we normally do. Directions that you're not allowed to use the calculator on your test, and that you just pass out the test after they take a tidbit. Homework is not due till Wednesday, so make sure you got the missing things for that together. Make sure you have other questions. You see me today, or you can forget this in your mind. Thanks. This will be like what is the before spring break, right? Like that's what will be our last test. The 18th, I think, right? So we have this week will be our test, and then we have next week, which starts the first week of March. So I think we only have 2 more weeks after this week, right? I think that's true. So I think the 9 weeks ends on the 11th. I might be wrong, but normally we end, and then we give report cards out before spring break. And so like the 18th is our snow day. High days on that Monday, and then we get out of school on the 18th. So usually, oh man, that means Pi Day goes on the new 9 weeks, not this 9 weeks. That means everyone gets to start the new 9 weeks with extra credit. Then absolutely. I just was reading that. I always want to ask. And then you should make the right decision.